Hello and welcome back to Math with Mrs. Becker. Today we are looking at Calculus, Chapter 1, Section 5. The main idea here is that you understand when a function is differentiable, and what that means is that you can find a derivative, meaning you can draw a tangent line at the point that you're looking at, okay? The other thing that we want to focus on is called continuity, and what that means is that you can trace over the graph going from the left to the right without having to pick up your pencil. Now again, this is another section where if you look in the textbook, they give you a lot of information which can be super overwhelming. So what I'm going to do in these notes is really just try to give you some examples, kind of keep it simple type of thing. Okay, so if you are trying to see if something is differentiable at an x value, okay? What that means is that you can draw a tangent line. Remember, a tangent line, it is a line that touches a curve at a point. So you could not have a tangent line on any of these things. Tangent lines do not exist on points or corners. A tangent line, by definition, is a line that touches a curve at a point without crossing it over. Okay, so if you ever have something that has a point, it is not differentiable because you could not find a derivative because you could not make a tangent line. Okay, another thing is you cannot have a vertical tangent line because remember, if you have a vertical line, your slope is undefined because vertical lines, they rise and fall. So there's a number on the top. If you're thinking of slope, it's rise over run. Well, vertical lines never run. So you end up with a 0 on the bottom. So you cannot have a tangent line that is vertical because it's undefined. And the derivative is a formula to find the slope of a tangent line. Well, if you have a vertical line, your slope is undefined, so you can't have a formula for that undefined value. Okay, so again, differentiable. You have to have a point there. That's another little rule. Let's say I have a curve, and I know we've looked at a few of these pertaining to limits. Let's say I have that. Another rule is you cannot draw a tangent line based off of this x value, because this is a hole. So what you really have here is this. You can't draw a line there because it has to touch the curve at one point. If you were to have it here at a hole, technically it's not touching. Okay, so I believe that's the last little rule where you're going to have something that's not differentiable. You cannot draw a tangent line at that point. You cannot have it touch a point that doesn't exist. You can't have it touch points. Okay, or corners. You cannot have a tangent line that is vertical because the slope doesn't exist, okay? Continuous. If something is continuous, what that means is that basically you can draw it without picking up your pencil. So again, that's the second thing you're looking at. They're going to say, is this function continuous? So what that means is, can you draw that shape right here? This would be continuous, but not differentiable at that point because it's a point. If this whole thing was one function, this would not be continuous because I have to pick up my pencil to go ahead and trace the second point. So continuous, simply, can you draw it without picking up your writing utensil? And what they'll do is give you a value of A. Can you draw over that value, meaning from the left or from the right, and not have to pick up your pencil? Now again, the book gives you a lot of different ideas. I did put them in the notes, but I really feel that rather than reading through this, which can be overwhelming, I gave you some examples with explanation, okay? This says, below are some examples of graphs with explanation for both differentiability and continuity. So here, if we are looking at x equals 0, at x equals 0, it's not differentiable because there's no tangent because this is a point. You cannot have a tangent at a point. You have to have a tangent line at a curve. So it's not differentiable at x equals 0. But it is continuous at x equals 0 because I can draw from either way and go over that 0 without picking up the pencil. So this is an example, not differentiable at 0, but it is continuous at 0. Okay, here is a visual of 1 over x squared. Now here, again, we're looking at 0. Well, 0, you guys, this is an asymptote. It's not differentiable. You can't draw a tangent line in an asymptote. Your tangent line has to touch the curve at one point. This thing, as it goes closer and closer to the y-axis, it's going to approach positive infinity, but it's never even going to touch x equals 0, okay? And again, just as a reminder, that is no limit because your limit cannot approach infinity. Infinity is not a value that it can merge to. It just means that the pattern continues upwards, okay? Also, going through 0. Can I go through 0 without picking up the pencil drawing this graph? Absolutely not. It's not continuous. That's an asymptote. There's a gap there. You would have to, even just to draw this much, you'd have to pick up the pencil to continue. So not differentiable. You cannot draw a tangent line at x equals 0. Not continuous. You cannot trace it without picking up your pencil. Okay, here's 2 more, because I really think that these visuals help more than anything. At least for me, they do, okay? Here is the line. Again, we're looking at x equals 0. If I try to draw a tangent line, a line that would touch at only one spot, this is not differentiable because here's a visual of, you would end up with a vertical line. If I'm trying to touch right here, if I want a line to touch at just one point, your tangent line would end up being a vertical line. You cannot have a vertical line because the slope is undefined. So I know that was one of the points that we talked about on the front side. And just to give you a visual of what that would look like, here is a sample of where you would end up drawing a tangent line that would end up being vertical, so it's not differentiable. You can't do that, okay? Continuous though, hey, I can go over the 0 this way, I can go over the 0 this way, I'm not picking up the pencil, so it is continuous. Okay, the next one. Is this differentiable at 0? Well, there's 2 different points at 0, and there's not a curve, so it's not differentiable. There's a jump in the graph. I have no idea where I would try to put a tangent line there. Not differentiable, cannot have a tangent line at 0. Again, not continuous, because we're based off of x equals 0. I'm coming along, boom, have to pick up the pencil. If you have to pick up the pencil, it's not continuous. Okay, so the idea behind these things, I think, are pretty simple. Differentiable, can you draw a tangent line? Continuous, can you trace over it without picking up your pencil? Again, though, guys, when you look at your book, 1.5, if you scan it, it looks like it's really difficult, okay? So if you feel yourself getting overwhelmed as you're going through the book exercises, please refer back to these notes. I tried to give you some good visuals with explanation of how things work, okay? Let's go ahead. There's 2 more, okay? The function is not differentiable at 2. Remember I said that technically this thing has a hole there. Well, you can't draw a derivative on a point if the point isn't there, okay? These 2 things are equivalent. That hole means that there's a space there. The definition of a tangent line, it has to touch at one point. They're saying, could you have it touch at 2? Well, no, that's where the hole is, okay? And same thing, this is not continuous because if I go ahead and I try to trace through that, you would be filling in the hole. The hole means that there's a gap. So it's not continuous because you cannot go through that line without picking up your pencil. Okay, the next one. The function is continuous and it's differentiable at all points. These arrows means that it's going forever and ever and ever. And so what you have to do is realize that you could go ahead and you could trace this and trace this and trace this. If you have tangent lines, you could draw tangent lines everywhere, so it's continuous and it's differentiable at all points. I'm going to hit pause quick because there's somebody at the door, and I'll see you back in a minute.